Function notation is just a different way of writing functions. So let's look at that. This means this is the function f of x. So this here, this line, that is the function f of x. The function f in terms of your input x. This is not f times x. No, that's not right. It's not f times x. This is the function f of x. That means that is your input. This is your function, and this is the input. All right, so input, that's always x, hence why this is x here, right? F of x is your input. Okay, f of -4. Since this is f of x, this is only saying, instead of f of x, x is 4, or -4. So I'm going to go 1, 2, 3, -4 is x. But I'm talking about the function at -4. So at -4, my function is 1, 2, right here, right? F of -4 is 2. F of 0, that is where it's 0, right? X is 0 here. So boom, touching my y, my output is 0. F of 3, think about that. What do you think I'm going to do? That's right, this is my x. 1, 2, 3. Go down here. And whatever that is, that's like -1.8 or something, we'll say. -1.8. F of -5, same thing. You're just going where x is -5, right here. And y is 0 again. Again, this is still a function. You can try the horizontal line test. Everything has just 1. But what about when f of x is 0? That's different because it's not telling you the input. What is it telling you? It's telling me what it equals. What was this? This was your output. So the output is 0, right? Where is the output 0? Well, the output is 0 when y is 0, right? Because y is the output. Right there. Right? So that's when x equals 0. Is that my only time? No, it's not, because we already did these two, right? We already know that f of x is 0 at -5 as well, so 0 and -5. This is okay, because these are inputs, and 0 is the output. That's okay. You can have two inputs with the same output. You just can't have one input that has multiple outputs. I know I keep saying that, but that's the definition. That's what you need to know, all right? That is what you need to know. This says my function f of x is 2x minus 3. I could graph this just like we saw it on the graph. I could do that. That's fine. But this says the function f in terms of x is 2x minus 3. So all this is saying, f of -2, that means x is now -2. That's all it says. So what do you think we'll do here? 2 times x, but x is -2. So 2 times -2 minus 3. 2 times -2 is -4 minus 3 is -7. F of 7. Guess what? X is now 7. So same thing. 2 times x is 2 times 7 minus 3. 14 minus 3 is 11. Go ahead and try f of -4. I bet you can do it. That's right. 2 times -4 minus 3, -8 minus 3 is -11. Same thing here. K of x, that's fine. They want to call it the function k, that's fine. Don't worry about it. K of x, k of 0. So x is now 0. So -7 times x, which is 0 plus 1. That's 0 plus 1 is 1. So same thing. You get the idea. I'm being repetitive. So we've seen what happens when you are given the input and asked to find the output. What if it's the other way? What if, like right here, it says g of h equals 80? Here's my function g of h. What happens if I don't know the input, but I do know the output? So it's asking, when does g of h equal 80? So we have to find the input. So the question we have to ask ourselves here is, what is g of h? G of h is 17h minus 5. If g of h is 17h minus 5, and that equals 80, then I can just set it equal to 80. And there you can solve from there. We can add 5 to both sides. 17h equals 85. And then divide by 17. And h equals, looks like 5. H equals 5. So 5 is the input when 80 is the output. So I know g of 5 is 80. Same kind of thing down here. G of h equals negative 345. That just means take g of h, 17h minus 5, set it equal to 345, solve. Add 5 to both sides, 17h equals negative 340, and divide by 17, and we find that h equals negative 20. So g of negative 20 is negative 345. So it's very similar, except you've got to solve. This is giving you the output, and you need to find the input.